So I'm coming from the National Science Council in Spain, from CSIC, and I'm working at an institute, that's the Microelectronics Institute in Barcelona. So focus of the institute is on microelectronics, building from circuits, sensors, actuators, many different applications, and in the nanofabrication and MEMS group. So we do nanofabrication, nanopatterning, of AFM, and so on. So today, my own focus is mainly on carbon nanomaterials, and today I want to bring a new idea to see if you may get interested, and also, I mean, any other idea coming up during the talk, it should go. I would also be happy to interact with you. Okay, so we speak of ICT, integrated communication technology. So we first think of a mobile phone, I think, with a supercomputer in our pockets. But the electronic devices, they are in many other places, in our entertainment. We have them also in education, and in when we do business and banking, and in health things, and so on, health devices and medicinal, okay? So when we open any of these electronic devices, we get a motherboard with some chips, and these chips are pieces, integrated circuits, that they are composed of these millions of very small electronic switches that allow to pass through the current or not in a controlled manner. So nanotechnology has been key here because it allowed to go through the scaling process, from going like from transistors that had these channels, these wires conducting the current that were like 10 micron long, to some transistors where now the channels are in the order of the nanometers. So they can be like 50 nanometer long and few nanometer thin. Okay, so these are how the scaling has gone over time. So the dimension of the transistors have gone down. So then we have been able to integrate more and more transistors per unit area, and this has resulted in having chips, microprocessors with more and more transistors. So the more and more transistors means that they are having more powerful, and also because we had more and more transistors per unit area, then the processes have not become more expensive, and everything is affordable, and we can enjoy it. Okay, so but scaling has some limits, and now this scaling of the channels, the little wires where the current goes through, is hitting some physical limits, and new things are required, because single defects in the channels, they can start inducing defects in how the transistors respond. And here, so nanomaterials come as a solution, and among these nanomaterials, there's nanomaterials like graphene in the two-dimensional form of carbon, patterned into a single wire, that's a graphene nanoribbon, or the carbon nanotubes when the graphene is rolled, or other two-dimensional materials like molybdenum disulfide. There are solutions that would meet or overcome the response by current solutions, like these pin-like structures in the current technologies that are in the market, or these nanosheet technologies that are the technology that is coming now in the few coming years. Okay, so these nanomaterials are very attractive because of the nanostructure. So they have superlative characteristics, but again, because the key is on the nanostructure, whichever defect here will be killing those super properties. And the fact that this structure needs to be controlled at the, let's say, atomic scale, it has implies new challenges to how the devices are made. So these are very new materials, so they need to be made with their own technologies. They are normally made else not on the wafer when the circuits are made, but aside, and then they need to be transferred and patterned. So this, the growth, the transfer, and the patterning induces a lot of defects. There's other bottom-up ways to make the materials that should result maybe in a more atomic precise structure, but that is much difficult to integrate. So here I'm coming with a solution that is based on making use of the catalytic and non-catalytic properties for the growth of the material. So it's a very simple, scalable strategy based on I'm showing here. So many of the growth of this material is based on a catalytic property of the substrate material. So by patterning the catalyst, then we can make the nanomaterial to grow on a surface or not. So then just by simply capping this catalytic material and just exposing the side of the catalytic thin film, then we can get some nano pattern then to grow the nanomaterial there. And this I published earlier, and it's proven, and I think it's a very nice path unexplored, and it should be it's the time to prove it for the next steps of the technology. Okay, so with this, I don't want you only to keep with you the process that I explained to you, because it's a little bit complex. But I want to convey to you that as a microelectronic institute, we have a very well-equipped clean room. It's 1,500 square meters. So it has all of or most of the equipment that you will be needing to build a semiconductor device. And we have two different lines. So there's one specific line that allows us to process CMOS compatible substrates. And there's another line for the other kind of substrates that maybe are tolerant to more contamination. So we can work with wafers that are 10 centimeter diameter, 15 centimeter diameter, and with chips and so on. Our institute is dedicated to research, but also to technological development. So if you are companies, you are very much welcome to contact us and to come for any development. And on my side, then I wanted to convey also in general that I'm good on, we are experienced on carbon nanomaterials, especially currently on graphene, growth, transfer by many methods, and integration. Then so metrology, the specific advanced approaches to grow specific structures of the graphene. And currently also we are diving into a 3D form, much easier to integrate form of graphene that is called laser-induced graphene. So here, this is a link for any one of you to access a better, more complete list of our capabilities. And just please contact me if you want for any interaction on whatever I was explaining today, either the idea on the templated growth and bottom-up growth, or whichever requirement comment on these capabilities that we are offering. Thank you.